Okay, so the central limit theorem helps reassure us that the mean is normally distributed. What that means is that we can use a slightly modified z-score formula. X bar minus the mu divided by the standard deviation over the square root of n. So it's a little bit different. Usually the z-score formula is x minus the mean divided by the standard deviation, right? So we get this divided by square root of n part here. That comes from the central limit theorem. So let's see. There's a mean of 11. Suppose so the mean is 11. So that's the mu. They're saying the weights of running shoes, the population weight, is 11. So that's what goes in for mu. That's like the weight of all the running shoes. And the standard deviation is 2, so I'm going to put that in for sigma. And the sample size is 40, so put that in, n equals 40. And then we're asked to calculate what is the probability that the resulting mean is more than 11.3. That's another way of identifying which number goes where. The number you're trying to test in the z-score always goes here. They're asking us to test and find the probability of 11.3. So that's what needs to go here. So we can compute this z-score. What's probably easiest is to figure out the denominator first. So 40 square root, I'm going to copy that number and then do what the fraction says, 2 divided by that number. We'll copy this decimal. That's the denominator. 11.3 subtracted by 11. Divide that by that denominator. That makes 0.95 when we round to the second decimal place. So that's a z-score, okay? Z equals 0.95. They're asking for the probability that the resulting mean is more than this value. So this is the normal distribution. It's centered at z equals 0. So z equals 0.95 is somewhere to the right. And they're asking for this. Tables by default, most tables, there are some that don't, but the table that we have here is telling us the probability actually to the left of our z-score. So z equals 0.95. That has a probability of 0.8289 for the left tail. So this right tail over here, you can just use the fact that it all adds up to 100% or 1 as a decimal and subtract 0.8289 from it. So there's our probability, 0.1711.